Okay, a quick reminder, our exam one is next week, Friday, and I will post a simple exam by the weekend and you guys can take a look. Next week, I'm not going to give you some more new material. We're going to review. So I will do some examples and look at those simple exam problem. And if you have questions, you can come to the lecture time, which is 4 to 5, Tuesday and Thursday. So today's lab, you click on the lab Friday week. The lab 3 is related to chapter 4. At the very end of the chapter 4, they talk about the grain size because we talk about the grain boundary and how do you determine the grain size, which is one of the topics that we are interested because the grain size might change how strong or how weak the material is. In chapter 7, there's going to be a topic talk about the strengthening mechanism, which grain size is one of the determination factor will determine whether the material is strong or weak. Typically, we will use the microscope to take a picture of the image, which is the structure of a sample. So this will be like a sample of some kind of structure. Now you can see the grain size is not like uniform. They have a many different kind of shape. Then how do we determine the grain size? So you have to do some kind of average. So in this lab, you have to use something that you learn in the statistics. You have to find the mean value of the grain size, and you also wanted to find the standard deviation, which tell you the variation of the size, right? So if the standard deviation is large, that means you have almost like a even number of the large grain and also the small grain. So if you got small deviation, that means the size of the grain is more like a uniform, more like about the same. Okay, so there is a video that show you how to determine the grain size by the method of what we call the interception. If you guys can watch this because I'm not going to use this time to play this video, but you can watch this to figure out, to get a good idea about how to do that. Click on the lab 3. This one here, you are going to submit your work by taking a picture of the file that you can write it on paper, but at the end you have to turn it in by either a file or a picture. This gives you the background, which is very similar to the textbook. I wanted to emphasize the equation that you see right here. So this equation is the equation that we use to determine the grain size. The LL, which in the textbook, they use the lowercase l, and here I put an uppercase L here. They represent the same thing. There should be a bar on the top, which represent this is a mean value. I couldn't type it at here, so I just use this one at here. That is equal to this one here that you will see in your textbook. The LT, P, and N, they represent different things. So let's see what those things represent. If you read through, you will see the LT is the total length of the test lines. So it is lines, meaning that you're going to draw several lines across the image that we just saw before. So we use those images to figure out what the grain size is, which I will tell you how we do that. The next thing that you see at here, okay, the next thing you see is the P. So what is the P here? This P here. So P is the total number of the grain boundary intersections. And that is kind of a tricky part in this lab, because how do you know the intersection and how do you determine the intersection, which is the thing that we need to do for this lab. So these two things, Oh, and then another one is the M. So the M is the magnification. So if you see some of the microscope image, they will put like magnification, like if you use microscope before, they will say, oh, this is 100 times or 60 times. But on the image itself, normally they won't give you this number, but how do you determine that? Which is one of the things we're gonna see in this lab. So these are the things that we are going to tell you how to do it. All right, so here is the procedure. So the first thing you need to do is to download this file. This file is the description that give you idea how to do this lab. But I make a summarize over here, which is after you download that file, what you need to do is you also need to download this result table. This is the one that you're going to turn in. So if I open this one up, and this has 2 pages. The first page is the data table. The next page is the sample that you are going to do. So how are you going to work on this? Let me explain. Let's go back to where we are. So go ahead and download this. This is the one that you're going to turn in. You're going to turn in this page where you're going to draw lines on this page, and you're going to turn in this one here, which will be, you're going to do some analysis based on this over here. You need a ruler. So if you, when you start, find a ruler, and find the millimeter one, the centimeter one. Don't use the inches. So we all going to use the SI unit. Okay, so in the result, you're gonna put these things. Okay, you can look at the data table. You will figure out. So let's just see how we do it. There's a ASTM standard tell you how to work on this. This method is called the mean linear interception method. And based on that equation, the LL equation, this equation over here. Okay, now what we try to find out is this one here, the LL. This LL tell you the information about the grain size. Basically, it's like how many, how many interception on the line that you draw. If you see a picture of the grain like this one here, you draw a line. If there are a lot of interception, that means the grain size is small. If you have less, then the grain size is large. So that's basically what the idea is. But things are getting complicated because everything is like a random. And the way that you draw the line or where you draw the line is going to be different. And that's why we don't just simply draw one line. We have to draw several lines. Typically, they will draw like 50 lines, but we are not going to do that. We don't have that time to draw 50 lines to repeat the same process. We're going to ask you to draw 10 lines. And let's look at how we get these values here. Let's start with the magnification. So M over here is the one that we are going to determine. So how do you determine M? Well, let's say you take a picture of using a microscope, looking at some small item. This is just an example to show you how we get that. The thing you will be focused on is this scale bar. Normally the scale bar, they will give a number to represent, say, oh, this lens represent, for example, like 1 millimeter. Okay, and if you measure the size of this inset over here, then this will be 1 millimeter. You draw a line from here to here. If this is the size of the inset, then we'll say, oh, using the scale bar, this is like 1 millimeter, 2 millimeter. This is probably like 3 millimeter. Right. So you will have an idea what the size of this is. But what about the magnification? Well, if you wanted to know the magnification, you have to use a ruler to actually measure the scale bar to see, what actually this is. So if you use a scale bar, you will find out, well, this is an enlarged version, but in realistic, this one will be smaller because it was magnified. The magnification is determined by you measure this one by the ruler and you look at the number they mark for this scale bar. So in this example, we use a ruler. I got 32 millimeter, which is the length of this scale bar length. And then the scale bar length, they give you like a 32,000 micrometer. Okay, so that's how they will tell you, well, this is how much the lens represent on the image. Then you divide these two, take the ratio of these two will give you the magnification. Okay, so the magnification is that you use this one here. And then let's see, okay. Yeah, so you have to use the ruler to measure this one. And that length you divide with this one here, divide with the number that they put in here. Let's say, so let's say your ruler give you 32. So this is 32. And you have to use the same unit. So this is a millimeter. And they put a mark on the scale bar. Okay, they didn't say what that is. They say the scale bar tells you this much of the length is 10 micrometer. All right, then what is the magnification? Well, the magnification is going to be the ratio of these two. So you have to do some conversion. This is 10 to the negative 3, 10 to the negative 6. So it's going to be 3.2 times 10 to the third. So that will be this much of magnification. Okay, so that's how you determine the first number in your lot. Any question about this? Right, let's look at the next one. So the next one is that in this equation, I need to know the P and LT. So what are those two things? The P represent the number of intersection. The LT represent the total length of the test line. Let's start with the LT here. Okay, so the LT is, if you see a sample like this, you're going to draw a line. So you draw a line like this one here, and the length of this line will represent one line length. But you are going to draw several of them. So you're going to draw, 1 and 2 and 3 and 5, etc., etc. And we want you to draw it randomly. Don't draw like a same direction. They don't draw at the same place. Just you have such a big page that you can draw different lines, the different orientation. So try to draw the lines at the different location and different orientation to get a better mean value for the grain size. So for each one of the line, let's say this is a line 1. And you also have the line 2, line 3, line 4, line 5. And you're going to draw 10 in this case. Each one of the line has a length. Okay, the length is the actual length. So you take a ruler. Let's say, for example, I think I want you guys to draw the line about like the longer the line, the better, because you're going to get a better number. So you draw like about like a 10 to 15 centimeter. Okay, and it's better that you draw the same length, but it doesn't necessarily to be the same length. So you draw 10 lines and you measure the length of each one of them and you sum them all together, that's LT. So the L, let's see, let me write it down. So the LT is the total length, which is the summation of each one of the lengths. Okay, so I is equal to 1, 2, in this case is 10. Okay, question about the LT. All right, the last thing about this is the tricky part here, is that once you draw the line over here, how do you count it? The P is that you have to count the intersection. So the way that we count the intersection, I put a rule over here, which is here. Okay, this is a rule how you count it. So when you draw a line, you're going to see, oh, this line is going to go across the boundary. So if you have an intersection, which means that the line go across this one here, then you have a 1. And this one, you have another 1. This one, you have another 1, right? Etc., etc., etc. This one here. So we got 7. But there's might be chances that if you draw a line, it happened to be some like intersection point with multiple, right? And if you have like a triple point, which means if you draw a line that goes through this one here, then you're going to count 1.5. And if your line happen to end at the boundary, like you draw a line, but it happened to end at here, then we're going to count this one as half. This will be 1, this will be 1, but this will be half. And this will be 1.5. So that's the rule. Any question about this?
What was that you said about the half? Sorry.
The half meaning the line end at the boundary.
Would you also count a half for the one on the left side? Oh, sorry. Go ahead.
No, that will be like a crossing. No, this won't. This will be just 1. So that's not. So let's do a practice. Let me just draw a line and let's practice how many P that you have.
Okay.
If you understand this, then you will be fine doing this. Let's say I draw a line, go across like this. Okay, so that's the line. And the way we count this is that, oh, this line starts from here and there's nothing on the left, then this will be the first one. This is a 1. This one, we have a triple point. This is 1.5. There's another 1. There's another 1. This one just right at the border, right at the boundary. So that will be half. So 1, 1.5, 1, 1.5. So your P in this case is 1, 2, 3, 4, 5. So P is
So it's 1.5. If it's at an intersection of multiple boundaries.
multiple lines. Yeah.
Okay.
Okay. Any other question about this?
Yeah, I have a question.
Yes.
If the line ends at a triple point, do you still count it as a half?
Oh, good question. If it ends at a triple point, I think so. Yeah. Let's just.
Okay.
Yeah. Let's make it. Yeah.
Thank you.
Let's make it happen. All right, any other question? That's a very good question. I never thought about that before. Let's use half. I'm going to check, what should be the number, but let's just use half. Okay, so that's what you have to do actually for this lab. Once you finish, then you just submit the table. Okay, let me go back to the table. Let's just take a look at the table. Then that will be the end for this pre-lecture. Then you guys can work on your own. I will stay in the room. If you have question, you can come back. Just ask a question. Otherwise, you just need to submit it by the end of today. So this one is not very difficult. Like I just wanted you to finish it. Don't wait until another week, then you never submit it. All right, so put your name, the day of today. You first have to determine the magnification. So as I said, use the ruler to measure the length of this. Then you use that length, divide 100 micrometer to get the magnification. That's how you determine the n. And then I will ask you to draw 10 lines. Each one of the line, you're going to put the length at here. Okay, that length is based on your it's based on your ruler. It's not based on the scale here. It's based on your ruler. Okay, you get a ruler and you measure the length. So I will say it's the best that you just keep the same. So you draw like one line here and then randomly draw a different line at different place and draw 10 of them. And each one of the line, you mark the length. You measure the length and you put the length at here. Okay, so that will be the length of 1 and 2, etc., etc. This one here is that you take this number to take a square. Okay, simply use this number as the square. This is the P. This is what we just did, the exercise. We count the number of interception. Over here, the sum represents the total of this column here. This one here, you put a total column of the square of the length. And over here, the mean is that if you got this number, let's say this is a 120, for example, and you have 10 of them, you use 120 divided by 10. And let's say this one give you this number, and then you have to divide by 10 as well. And the reason you need this is because if you open the other file that I told you, there is like an equation to tell you how to get a standard deviation. And it depends on the mean value of this one. It also depends on this mean value of the square value. And there's a standard error equation, confidence interval equation as well. So you use that to get the result. The one last thing you have to do is to determine the grain size number. And that one is based on the equation from your textbook, which is this equation. Once you find the LL bar, which is based on that equation that we show you, the equation on campus doesn't have the bar, it should have the bar. So that value, you take the log of that, multiply with this number minus this constant, that will give you a number called G. This G number is what we call the grain size number. So when you do the homework of this chapter, you will have some problem which will ask you to do this. So this could be one of the problem in your exam. Make sure that you know how to find the LL, how to convert it into the G number, in this lab. All right, any question? This will be how you are going to work, how you are going to do for this lab.
I just got a question about LT really quick. You said that was sigma times Li.
Yeah, the sigma represents a summation. So you do the summation of these. So you simply just sum all these numbers here.
For the LT?
LT is the summation of these number here.
Okay.
Yeah.
Well, you said it's sigma
So
times.
this is a
Oh,
LT.
okay. Okay. All right, I got it.
Yeah. Magnification is this one here. And we should have a column here. This one will be the sum of this interception. This should be the P.
Do you want us to put that in?
It should be, yeah, it will be better. Then it will be easier for you to determine that number.
Okay.
Yeah. Okay, any other question? So you got an M over here. You sum all these number to be the P. You sum all these number as the LT, and then you got the L bar to be LT over P times A. Then you use this one to get the G number, which is the equation that I listed at the bottom here. This equation is the equation in your textbook as well.
M is gonna be equal to mass?
What?
What's M equal to?
Magnification.
Okay.
Magnification. Remember how, I told you how to do the magnification?
Yeah, it's just, I'm used to M being mass. So I was
Okay.
asking.
Magnification, you use a ruler to measure the actual length of this bar. And use the number divide with this number over here. That is your magnification. Okay, so you have to print out and use the ruler to measure this length.
And Professor, I did find out that the library is open today from 10 to 2 p.m.
Okay, great. So if you could, then you can go there to finish it. All right, any other question?
Yeah, I have a
One more.
question, Professor.
Sid?
You can go ahead, Kevin. It's fine.
Oh, thanks. This will be quick. When you're drawing L, these should all be the same, right? So on the chart where we have 10 boxes for L, they should all be, let's say we're using a 10 centimeter ruler, then they're all going to be 10, right? And then L squared is just going to be the same for all those as well.
Yeah,
or we go ahead.
It is not necessary to be all the same, but it will be better.
Okay.
Say. So because if you draw it too short, then it doesn't really represent a good number for in average. So it will be better that you draw about the same length. And it's better that you draw the longer line. So you don't draw like, oh, you have 5 centimeters short one. Yeah,
Okay.
you're gonna save some time by counting the number, but you're not gonna get a good value. So make the line longer. If you can go across, almost like across the whole page, that'll be the best.
Thank you.
Yeah. So it might be the best if you draw the line, go like go across like this way, because this is a longer in this way, right? Then you can get as long as the line is. But again, the line doesn't have to be all the same. You might have a little bit difference, which is because if you change orientation, you won't be able to go across that much. This is probably the most time consuming part because you have to count the number.
Right.
Yeah, otherwise it should be simple.
Got it. Thank
Oh,
you.
wait,
Yeah.
so the P doesn't have to be 7 on every trial, right? The value for P?
The value for P, no, the value for P depends on how you draw the line.
Okay,
Right, the
and do you
P
think
is
that
the
it's
number crossing. So this line here might not have the same number of the crossing of this one here.
okay,
Yeah, so P is not going to be the same. Even if
Alright.
you have LT is the L is the same, it's not going to give you the same.
okay, and it's better if we draw longer lines at the same length. Is that what you said earlier?
Yeah, if you draw a longer line, that will be better. That will give you a better number.
Alright, no problem, thank you.
Okay. Any other question? These are good questions.
So when we're drawing like the 10 to 15 centimeter lines on the image, is there a conversion that we're supposed to do to get it into microns?
It do a conversion to get what?
Into microns for
Into
L?
the micron. You don't so I guess you write a micron, so you have to do a conversion. Yeah. So if you draw like a 10 centimeter, let's say for example, and you convert it into the micron, then you put that in your LT.
Okay, thank you.
All right, any other question about this? All right. You're free to leave, or if you want to stay here and while you're doing, you can ask question. I'll be here to answer your question. Again, for those of you just get in the lab, I want to remind you next week, next Friday, we're going to meet on campus. We're going to have exam one cover chapter 1 to chapter 4. The next week will be a review, which we're not going to talk about new materials. I will post a sample exam for you to take a look what the exam looks like.
And then I'm gonna go to the library. So this Zoom is just gonna be open. I can just rejoin, right?
Yeah.
Okay. All right. I'll see you back in a little bit.
Okay. Sounds good.